Okay, today we're going to talk about basic antiderivatives. So far we've been talking about the integral as the area under a curve. It can also be found using the Riemann sum. And last time we talked about the fundamental theorem of calculus, which is to say that the area under a curve, which can also be found using the Riemann sum, is f of b minus f of a, where f is a different function. Big F is a different function than little f. Its derivative is little f. And this leads us to wonder, how do we find these functions whose derivatives are our given function? First, a word of notation. Because of that integral from a to b f of x dx is called a definite integral, and it represents a number. It's the area under the curve, where the area above the x-axis counts positive and the area below the x-axis counts negative. What we're going to say is the integral without the limits a and b is an indefinite integral. And this is the most general function big F of x whose derivative is your f of x. So a few examples. So in other words, the integral of x squared dx is the most general function whose derivative is x squared. It is f of x where its derivative needs to be x squared. And you'd think, well, f of x could be x cubed. No, because the derivative of x cubed is 3x squared. We only want 1x squared. How about f of x is 1/3 x squared? Yes, that works. The derivative of that is 1/3 x cubed is 1/3 times 3x squared, which is just x squared. That works. But so this one is out, that one is in, but it is not the most general function because there are other functions. We could have had f of x was 1/3 x cubed plus 5, because the derivative of that function is, again, x squared, because the derivative of 1/3 x cubed is x squared, and the derivative of 5 is 0. In fact, we could have had 1/3 x cubed plus 7, or 1/3 x cubed minus 100. Any constant fits in there. So the most general answer is the integral of x squared dx is 1/3 x cubed plus c, where c is a constant. And this is going to be the general rule. The general rule is, if you don't have an a and a b here, if you don't have limits of integration, that's what those are called, then you're going to always have this plus c, because you never know what constant might have been added there, because the derivative of any constant is 0. They always disappear. If you do have limits of integration, then when you find your antiderivative, you're going to have to plug in b, plug in a, and subtract.